Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find all the papers with their detailed PDF solutions. For a better preparation of your exams, must download our app. The link is available in the description box. So students, today I'll be solving JEE Mains 2024, 27 Jan. Shift 1 paper. I'll be solving the mathematical part of the paper in this particular video. So let's start with that. A very best of luck. Here we go. Question number 1. It says n minus 1 CR is equal to k square minus 8 n CR plus 1. If and only if you have to find out the range of k. Okay, so first thing, let's pick up this n minus r CR is equal to k square minus 8 into n CR plus 1. So this will be n minus 1. This is equal to n minus 1 factorial upon r factorial upon n minus 1 minus r factorial is equal to k square minus 8 into n factorial r plus 1 factorial n minus r plus 1 minus, like this will be in the brackets, right? Okay, let's write it down. So it will be like this. So let it be n minus 1 only. R factorial, let it be r factorial only. This is n minus 1 minus r factorial is equal to k square minus 8. Let's open up n factorial. This can be written like this. And r plus 1 into r factorial into n minus r minus 1 factorial. Let's do the cancellations. So they will be cancelled out. This will be cancelled and this will be cancelled. I'll be left with the 1. Yes, I'll be left with 1 is equal to k square minus 8 into n upon r plus 1. Or you have r plus 1 upon n is equal to k minus 8. Now just note on this equation. I have two situations from here. One thing I would like to discuss. One thing you were having over here. See, what is the case now? You are having three variables, r, n, and k. What do you have to find out? You have to find out the range of k. I don't have anything like to just go for k, but now I can look for another things which are possible over here. If you look at this n minus 1 CR, one thing, you are having n minus 1 CR. N minus 1 will always be less than equal to r, right? Sorry, it will be greater than equal to r. It will be greater than equal to r, n minus 1. Let's write it again. N minus 1 CR. Here n minus 1 will always be greater than equal to r. That will give you n is greater than equal to r plus 1 or r plus 1 upon n is less than equal to 1. Okay, so now let's get back to this equation. Here I am having two things. This was my equation. So from here, one thing is that k minus 8, it's always positive. Second thing, you had k minus 8, k square minus 8 is equal to r plus 1 upon n, and this is less than equal to 1, right? So that makes k square minus 8 is also less than equal to 1, which makes k square is this, or k lies between minus 3 and 3. One thing. Second thing, from here you have k square is greater than 8, so k is greater than plus minus 2 root 2. That means k will lie in the range of minus 2 root 2. No, wait, I'll not write it like this. Let's write it like this. From here, you will have the range of k as minus 2 root 2 is less than k is less than 2 root 2. So that means if k will have the range, k will belong to minus infinity and minus 2 root 2 union 2 root 2 and infinity. All right, and these are the two ranges of k. Combining both of them, you will get that the k lies between minus 3 minus 2 root 2 union. This will be, sorry, closed. One union. Here will be 2 root 2 3. So this is the required answer to the question. Let's check with the options. You have I think the first one. Yes, this is the right answer to the question. Hope you're clear with this. Next is the question number 2. The distance of this point from this line along this line is. Okay, so here you are having, let's see, this is the point, let this be the point A. You have to find out the distance of the point 7 minus 2, 11 from this line. This is the given line, x minus 6 upon 1, x minus 6 upon 1, y minus 4 upon 0, z minus 8 upon 3. So here is the second point, B. Let it falls perpendicularly on B. If I get to, this is the perpendicular line, if I get to know the coordinates of B, I'll get my question's answer. Okay, now I'm repeating the question, the distance of this point from this line along this. So here you have the line 5 minus 2, x minus 5 upon 2 is equal to this, is equal to this, right? So what will be the coordinates of B? B will have the coordinates as, let's say this is equal to lambda. So B will have the coordinates as 2 lambda plus 7, comma, minus 3 lambda minus 2, 6 lambda plus 1. These will be the coordinates of B. Now you are saying that, of course, B lies on this line. B lies on this line. So therefore, the given line was x minus 6 upon 1, y minus 4 upon 0, z minus 8 upon 3. This was the given line. Let's fill in the x, y, z values over here. You will have a 2 lambda plus 7 minus 6 upon 1 minus 3 lambda minus 2 minus 4 upon 0 is equal to 6 lambda plus 11 minus 8 upon 3. So from here, you have a minus 3 lambda minus 6. This is equal to 0, or you have lambda is equal to 2, minus 2. Okay, now let's find out the coordinates of B. We will have the coordinates as this was 2 lambda plus 7 minus 3 lambda minus 2. 6 lambda plus 11. So now B will have the coordinates as this will be 3 and 4 minus 1. These are the coordinates of B. We already have the coordinates of A. We got the coordinates of B. We are done with the question. So A had the coordinates 7 minus 2, 11. B is having 3, 4 minus 1. You have to find out what is AB. AB is given by root of 7 minus 3 square, 4 plus 2 square. This will be this, 11 plus this. So 4 square, let's write it. We have 16, 36 and 144. This is equal to 14 units. So this is the answer to the question, 14 units. Right, the distance 14 units. We have option B as the correct answer. Hope you are clear with this. Let's move to the next question, number 3. Let x is equal to xt, y is equal to yt be the solutions of these two differential equations. Let's write down the differential equations. First one, dx upon dt plus ax is equal to 0. Then you have dy upon dt plus by is equal to 0. Let's say this x is equal to xt and y is equal to yt. These are the two solutions of these two differential equations. And a and b, they are real numbers. You are given that, let's write, when t is 0, x is equal to 2. When t is 0, y is equal to 1. 3y 41, this is equal to this. And you have to find the value of t for which x t is equal to yt. Okay, now, okay, these are the things which are given. Let's go for the solution now. So first, the differential equation was dx upon dt plus ax is equal to 0. That gives you dx upon x is equal to minus a into dt. Let's integrate both the sides. You will have natural log x is equal to minus a into t plus c. Now, you are given the question at t is equal to 0. You have x 2. So let's use this equation. You have natural log 2 is equal to 0 plus c. So that gives you c is equal to this log of 2. Okay. Yeah. So what is this equation becomes now? Let's write it over here. Let's say this is equation 1. So now equation 1 becomes log x is equal to minus 8t plus log 2. This was the first one. Okay. Also, you have one more thing. Let's write it like this. So here you have natural log x minus natural log 2. This is equal to minus 80. Or you will have a log. You will have log this x minus 2. This will be x by 2. This is equal to minus 80, or x by 2 will be e raised to power minus 80, or x will be equal to 2 into e raised to power minus 80. Okay. Now let's say this is equation 2. Right. Now let's pick up the second one. We are done with the first one. We have got the a function. Now let's go with the second one to get the y function. You have here dy by dt is dy by dt plus by is equal to 0. So you have dy upon dt is equal to minus by, or you have dy by y is equal to minus this. Let's integrate again on both the sides. You have natural log y is equal to minus bt plus the constant c. So, right, now you are given in the question that at t is equal to 0, you have y is equal to 1. So this becomes log 1. This equation now becomes log 1 is equal to 0 plus c. Log 1 is equal to 0. That means you have c is equal to 0. Now what does this equation becomes? Let's say this is equation 3. So now equation 3 becomes natural log y is equal to minus b y. That's it. And now this will be y is equal to e power. Sorry, here was t, not y. Minus bt. Okay, so we got the value of x and y. This is x and y. Let's say this is equation 4. Now you have, let's write it again. You have x is equal to 2a, sorry with this, 2e raised to power, 2e raised to power this, y is equal to b raised to power minus bt. Now, according to the question, you are given in the question that 3y1 is equal to 2x1. So you're given over here 3y1 is equal to 2x1. This is given over here. So that means here the t is equal to 1. Here t is also equal to 1. So this makes 3 into e power minus b into 1 is equal to 2. Now this is equal to 2 again, e power minus a into 1. So let's write it properly. You have 3 into e raised to power minus b is equal to 4 into e raised to power minus a. Or you have from here that e raised to power a minus b is equal to 4 upon 3, right? 4. Now you have to find out what you have to find out. We have to find out the value for t for which both of them are equal. Okay. So for both of them to be equal, what do you need is 2 into, I always write a over here, e raised to power a minus at is equal to, it was e raised to power minus bt. So let's concatenate them. You will have e raised to power at minus bt is equal to 2, or you have at minus bt is equal to natural log of, no, sorry, not the natural log. This will be, wait, we already have one value. This was the one, right? I'll be using this value over here. Okay, so this was equal to 2. Let it be like this only. So this is equal to e raised to power a minus b into t is equal to 2. E raised to power a minus b, this is equal to 4 by 3. This is raised to power 2. T is equal to 2. So this will be log 4 by 3 to the base log 2 to the base 4 by 3 is equal to t. So this is the value of t for which the value of both the functions will be equal. Okay. So that makes yeah, option D to be the right answer. Hope you are clear with this. Let's move to the next question number 4. If AB be the orthocenter of the triangle with the vertices 1, 2, 2, 3, 3, 1. Let's make that triangle first. So we are having a triangle with these 3 vertices. See, if you had only this much question, it would have been so easy to go for. But you have these I1 and I2 also. And you have to find out this thing. No problem. Here is A, here is B, 2, 3. Here is C, which is 3, 1. Okay, so let's say this is E. Okay, and this is, let's say D. So this is the orthocenter. You know what is the orthocenter? Here the perpendicular bisectors meet. So, not the bisectors, they're the perpendiculars meet. So this is the orthocenter. And let's make the equation of CE. I don't know the coordinates of CE, but I can see one thing. This is perpendicular, right? CE is perpendicular to AB. Let's find out the slope of AB. Slope of AB, you know, this is given by y2 minus y1 upon x2 minus x1. This is equal to 3 minus 2 upon 2 minus 1. That is equal to 1. So slope of AB is equal to 1. You know, CE is perpendicular to AB. So that means slope of CE will be minus 1 upon slope of AB. So this will be minus 1 upon 1. That will be minus 1 only. Right. Let's frame the equation of CE now. We have one coordinate. We have the slope. Let's make the equation of CE. That is given by y minus y1 is equal to slope of CE x minus x1. So you have y minus 1 is equal to minus 1 into x minus 3. This will be equal to y minus 1 is equal to minus x plus 3, or you have x plus y is equal to 4. This is the equation for CE. Now one thing that orthocenter, this is the equation of the line x plus y is equal to 4. So let the orthocenter be given by AB. So orthocenter lies on the line x plus y is equal to 4. So that means you have A plus B is equal to 4. Correct? Now let's get to, we still have to find out the coordinates of orthocenter, but we are also given that I1 this integration and this integration. Let's write down the two integrations first. So you have, I'll pick up the first one first. I1 is given to you as A, limits A to B, x sine 4x minus x square dx. I'll be using the King's rule. You know that King's rule. This is fx dx can be written as limit A to B, f of A plus B minus x dx. All right, so King's rule, let's apply it over here. You have limits A to B, x. This will be A plus, okay, let's write down A plus B minus x sine 4 A plus B minus x minus A plus B minus x square dx, right? And we just saw over here that A plus B is equal to 4. Let's use this. You have integration 4 minus x sine, this will be 4 minus x minus 4 minus x square dx. So that's A to B, 4 minus x sine 16 minus 4x minus, this is 16 plus x square minus 8x dx. So this is equal to 4 minus x sine 16 minus 4x minus 16 minus x square plus 8x dx. 16 will cancel, and this is 4 minus x sine 4x minus x square dx. That was equal to your I1. Okay, and what was your I2? In the question, you had I2 as, let's see, what was your I2? Integration A to B sine 4x minus x square dx. Now let's do one thing. Add both of them. Okay, you have a I1 plus I2. No, don't add both of them. I mean, not add both of them. What is this is, let's open up this one. Let's write down I1 again. So this is equal to integration a to b 4 minus x into sine 4x minus x square dx. Okay, I'll open up this one. So you have I1 is equal to integration a to b 4 into sine 4x minus x square dx minus integration a to b x into sine 4x minus x square dx. Okay, now what is your I2? So I'm taking this. This is equal to 4 I2. This is equal to your I2, right? Look over here. This was your I2. So this is equal to 4 I2 minus I1 is equal to I1. That gives you 2 I1 is equal to 4 I2, or you have a 2 I1 is equal to 2 I2. So I1 upon I2 is equal to 2. What you have to find out in the question was 36 I1 upon I2. So 36 I1 upon I2. For that, let's multiply both the sides with 36. So you have 72 as the answer. 72 is the right answer to the question, and first option is the correct answer. Hope you are clear with this. Let's move to the next question then. Question number 5. A denotes the sum of all the coefficients in the expansion of this, and B denotes the sum of all the coefficients in the expansion of this expression. Then which of the following is true about A and B? So first expression, you have 1 minus 3x plus 10x squared. You are given that the sum of coefficients for this is equal to A. So A will be given by, here is 1 minus 3 plus 10. This is whole raised to power n, not 2. Right. So this is 8 raised to power n. If I'm putting x is equal to 1 over here. So the sum of coefficients A is given by 8 raised to power n. Whatever the value of n will be, the sum of coefficients will be equal to 8 raised to power n then. Now the second expression, 1 plus x square raised to power n. Here you are having B as a sum of coefficients. So B is equal to 1 plus, if I'm putting x is equal to 1, that's 1 plus 1 is raised to power n, that is 2 raised to power n. So you have A as 8 raised to power n, and you have B as 2 raised to power n. Now B denotes, okay, fine. What you have to find out? A and B's relation. That's right. You have A as this, B as this. So from both of them, you have A is equal to B raised to power 3B cube. That makes the first option as the correct one. Hope you're clear with this. Next is question number 6. The number of common terms in the progression of 4, 9, 14, this up to 25 terms, and 3, 6, 9, 12 up to 37th term is. You are having two series over here. 4, 9, 14, 19 up to 25th term, and the second one 3, 6, 9, 12 up to 37th term. Right. What will be the 25th term? I need to know this, and the 37th term. So T25, you know the formula is first term plus n minus 1 into D. Here D is equal to, A is equal to 4, D is equal to 9 minus 4, which is equal to 5, n is equal to 25. So what will be the 25th term? T25 will be equal to 4 plus 25 minus 124, multiply 5. That's equal to, this will be, it will give me, this will be 124. Okay, so now the series become 4, 9, 14, 19 up to 124. So now the second one, T37. I have to find out. For that, first of all, you have the first term as 3 and the common difference as 6 minus 3, that is also equal to 3. N is equal to 37. So you have T 37 is equal to 3 plus 37 minus 1 into 3, which is equal to 3 plus 36 into 3, which will give me, wait, 36. This is 111. Okay. So now the series over here will be 3, 6, 9, 12 up to 111. Now let's get back to the question. You have to find out the number of common terms in them. See, the very first common term is 9. Okay. So first common term is equal to 9. Now, LCM of, let's say, D1 and D2. These are the two series. So you have to do LT1 N1 and A2 T2 N2. So you have to take the common, because I have to move in the progression of for both the series. So I have to take the LCM of D1 and D2. Here the D1 was 5 and D2 is 3. So LCM is equal to 15. Now the series will be 9, 24, 39. Now, so on. What will be the last term over here? See, here you're having 124 and here you're having 1111. I'll obviously pick up the smaller one, obviously, right? So the last one is this. I have to go, I mean, smaller than 111. This will be 9, 24, 39. After that, you have 54. Then you will have 69. Then you will have 84. Then you have 99. And yeah, after that, it will be greater than 115, 111. Okay, how many terms? 1, 2, 3, 4, 5, 6, and 7. So there are 7 terms, right? That makes C option as the correct answer. Hope you're clear. Next question number 7. If the shortest distance of this parabola from the center of the circle this is D, then D square is equal to. First of all, see the shortest distance. This is a parabola. This is a right parabola like this. Okay. Now, this is the circle. Let's write down x square, this, this, this. What will be the center? It is given by minus g minus f, minus half the coefficient of x, minus half the coefficient of y. So 2, 8. This is the center for the circle. Now, equation of the parabola, y square is equal to 4x. Here you have, if I compare it with the general equation, y square is equal to 4ax. You have a as 1. Now, this is the equation of the parabola. Equation of normal to parabola is equation of normal to the parabola is given by y is equal to mx minus 2m minus m cube. Now, this normal passes through the center of the circle according to the question. This normal passes through the center of the circle, 2, 8. So what will this equation now will be? 8 is equal to m into 2 minus 2m minus m cube. From here, you will have m cube is equal to minus 8, or m will be equal to minus 2. So now, what is the point? Any point P on the parabola is given by am square minus 2am. So a, I told you it's 1, right? This will be 4, 4. So this is the point P, and the center we already know this is 2, 8. What we need to find out is PC. This is equal to 4 minus 2 square, 4 minus 8 square. That will be 2 square, which is 4, and this will be root 20, right? This was equal to D. This is what, right? You are told in the question that this PC is equal to D. You have to find out D square. That means you have to find out D PC square. That is equal to 20. So 20 unit square. This is the answer to the question. Okay. Option C stands to be the correct answer. Okay. Hope you are clear with this. Next, question number 8. Question number 8, if the shortest distance between these two lines is 6 by root 5, then the sum of all possible values of lambda is. Okay. First of all, these are the two lines. X minus 4 upon 1 is equal to y plus 1 upon 2 is equal to z plus 0 upon minus 3. And the second one, x minus lambda upon 2, y plus 1 upon 4, z minus 2 upon 5. Distance, shortest distance between the two lines is given by this. What is the formula for the shortest distance? It is given by modulus of A vector minus B vector dot product cross product of D1 and D2 divided by their magnitude. Okay, so now what is A? See, the A vector from this is given by 4, then minus 1, then 0, and the B vector is lambda minus 1 and 2. What is A minus B? This is 4 minus lambda and 0 and minus 2. All right. What is D1 vector and D2 vector? This is equal to 1, 2, minus 3 and this, right? Let's check. 2, 4, minus 5, 1, 2, minus 3. Yes, that's it. So what is the cross product of D1 and D2? The cross product will be given by I, J, and K. 1, 2, minus 3, 2, 4, minus 5. This is equal to I minus 10 plus 12 minus J minus 5 plus 6 plus K 4 minus 4. So that's 2I minus J plus 0K. This is D1 cross D2. Let's find out the magnitude of this. This is equal to root of 2 square plus minus 1 square, which is equal to root 5. Now let's find out. Let's fill in everything in this equation. The shortest distance D, shortest distance T is given by modulus of A minus B dot product with D1 cross D divided by the magnitude. You are given in the question that this is equal to 6 upon root 5. So from here, you have 6 upon root 5 is equal to A minus B was 4 minus lambda 0 minus 2. 4 minus lambda I 0K minus 0J minus this. Dot product with this was 2I minus J plus 0K. Whole thing divided by the magnitude, that is root 5. First of all, these two will cancel out and you will have 6 is equal to, let's find out the dot product. This will be 2, 4 minus lambda plus 0 plus 0. So you have 2, 4 minus lambda is equal to plus minus 6, or you have 4 minus lambda is equal to plus minus 3, which gives you 4 minus lambda is equal to 3, or 4 minus lambda is equal to minus 3. From here, you will have lambda is equal to 1, and from here, you are having lambda is equal to 7. So these are the two possible values of lambda. What you had to find out in the question was sum of all possible values of lambda. So required sum of both is equal to 8. That's it. You have option B as the correct answer. Hope you understood this. Next is question number 9. If integral of limit 0 to 1, 1 upon this is equal to this, then you have where A, B, and C are the rational numbers, then you have to find out the value of expression 2A plus 3B minus 4C. Okay, let's write down the integral 0 to 1, 1 upon root 3 plus x, this dx. This is equal to integral 0 to 1. Let's rationalize. You will have root 3 plus x minus this a square minus b square. So this is 3 plus x minus this dx, or this is equal to 0 to 1 root 3 plus x minus this dx, this will be 3 plus x minus, so this will be 2. Okay, now you will have 1 by 2 integral. Let's split up the integrals also. This will be this limits 0 to 1 minus 1 by 2. This limits 0 to 1. So 1 by 2. This will be 0 to 1. 3 plus x by raised to power 1 by 2 dx minus 1 plus x raised to power 1 by 2 dx. So this will give me 1 by 2 into 3 power. This will be plus 1. So raised to power 3 by 2 divided by 3 by 2 minus half 1 plus x raised to power 3 by 2 divided by 3 by 2. This will be 2 will cancel. This will be 3 plus x upon 3 raised to power 3 by 2 minus 1 plus x raised to power 3 by 2 divided by 3. Here the limits were 0 to 1, 0 to 1. So same thing. Now this will give me, let's fill in the limits. 1 by 3 outside. This will give me, this is first of all 1. So it will be 4 raised to power 3 by 2. Plus minus 3 raised to power 3 by 2. Okay, minus, now here will be 1. So this will be 2 raised to power 3 by 2 minus 1 raised to power 3 by 2. 1 by 3 outside, this will be 2 raised to power 3 minus, this will be 3 root 3 and this will be 2 root 2 plus 1. So this will give me 1 by 3 here. This will be 9 minus 3 root 3 minus 2 root 2, or this will be 3 minus root 3 minus 2 by 3 root 2. Now let's compare it with the given expression a plus b root 2. This was equal to a plus b root 2 plus c root 3. From here you have a as 3, b as minus 2 by 3 and c as minus root 3. No, minus 1. So these are the value of a, b, c. To find was the expression 2a, 3b minus 4c, which will give me 6 minus 2 plus 4, that is equal to 8. So this is the required answer. Option D. This is the correct answer to the question. Hope you're clear with this. Let's move to the question number 10. S is given by this. Suppose M is a set of all subsets of S, then the relation R, which is having the ordered pair AB, such that A intersection B is equal to phi and A, B belong to M is. So first thing, you are having S set as 1, 2, 3 till 10. Now R is the relation such that AB exists, for which such that AB is not null, not phi, and they both belong to M. Now, for the first one, you're having 3, symmetric, reflexive, and transitive. So for reflexive, M is a subset of S given. So phi belongs to M. And you have phi intersection phi, phi. But relation is A intersection B is not equal to phi. Therefore, it's not reflexive. The second one for symmetric. A relation B, you have A intersection B is not equal to this, and B R A is this. See, if A intersection B is phi, then B intersection A is also phi. So it is symmetric. Okay, now let's check for transitive. You have A as A will be 1, 2, 2, 3. B will be 2, 3, 3, 4, and C will be 3, 4, and 5, 6. Now, A are B and B are C, but A doesn't relate to C. So it's not transitive also. All right. So now let's check with the option. It's not transitive, not reflexive. It's only symmetric. No, 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 this. You have D option as the correct answer. Hope you're clear with this. Let's move to the next question then. Question number 11. Question number 11. If S is the Z which contains Z, contains Z, that is the complex number such that this is equal to this, then how many elements are there in S? This is what you need to find out in the question. See, instead of going for this x plus iota thing, so instead of going to that, you can see these as the three distances between the two complex numbers, right? So the first one, you are having a z minus iota. This is the distance between z and the coordinate, which is 0, 1, and z plus iota. This is the distance between z and 0, minus 1. So the last one, z minus 1, distance between z and the point 1, 0. So let's plot them on the coordinate axis. This will be given by these points. So this is the point, let's say 1, 0. This is the point 0, 1, and this is the point, this one. So these are the 3 points. Let's combine them. Now this forms a triangle. This ABC, let's name them. This is, let's say, point A, this is point B, and this is point C. Now ABC is a triangle. And from here, it's circumcenter. This is the only point which is having these three. This point, this is the circumcenter, which is equidistant from B, from C, and from A. So these distances are equal, equidistant. Circumcenter is the only point which in this case is your origin. So circumcenter will be the only point whose distance from A, B, and C are same. So how many elements are there? There is only one coordinate such. That means the answer to the question is 1. This is the answer, and you have first option as the correct answer. Hope you got that. Next is question number 12. 4 distinct points, this, and this lie on a circle for k value as. If I plot, you see I'm having these finite points over here. So the first one is your, when you have the origin. Let's have this. Circle is passing through the origin. Also, circle is passing through this point 1, 0, and this point that is 0, 1. Let's say this is the point B, this is the point A, and this is the point O. So now, if you look over here, this distance is equal to this distance also. This is a 90-degree angle. So that means if I see AB will be the diameter of that circle. There are 2 reasons. First is OB is equal to OA and angle BOA is 90 degree. You know, the diameter subtends 90-degree angle on the circumference of the circle. So that means AB is the diameter. So the circle would look something like this. Okay. So this will be your circle. Now you have the coordinates A as 1, 0, B as 0, 1. You know the coordinates of the diameter. You can form the equation of the circle that is given by x minus x1, x minus x2 plus y minus y1, y minus y2 is equal to 0. So here you have, this is x1, y1, x2, y2, x minus 1, x minus 0 plus y minus 0, y minus 1 is equal to 0. That makes x squared minus x, y squared minus y is equal to 0, or you have x squared plus y squared minus x minus y is equal to 0. Now, the third point, this 2k, 3k also lies on this circle. For the point 2k, 3k, this lies on the given circle. So you will have 2k square plus 3k square minus 2k minus 3k is equal to 0. 4k square, 9k square minus 5k is equal to 0. 13k square minus 5k is equal to 0. Let's take the k common. 13 minus 5, 13k minus 5 is equal to 0. That gives you either k is equal to 0 or k is equal to 5 upon 13. K can't be 0, right? Because we already have, if I put k is equal to 0, this will become the origin, which is already given over here. That means k is equal to 5 by 13. That's it. You needed the answer. K is equal to 5 by 13. We have C option as the right answer. Hope you're clear with this. Next is question number 13. Consider the function fx for which you are given that this is equal to this for x less than 3, equal to this function for x greater than 3 is equal to b for x is equal to 3. Now, you are given that this denotes your greatest integer function less than or equal to x if S denotes a set of all ordered pairs AB such that fx is continuous at x is equal to 3. Then the number of elements in S is. So you are having, first thing you are given in the question that fx is continuous at x is equal to 3. That means f of 3 minus will be equal to f of 3 plus will be equal to f of 3 for the function to be continuous. You know this thing. Now let's find out f of 3 minus. For this 3 minus, I'll be considering this function. This is equal to a upon b. Let's factorize this. Let's split the middle term over here. So you will have two such terms. This will be, yeah, this will be 7x minus, okay, let's write it properly first. I'm getting confused. So this is, I'm taking the minus outside. So this will be x square minus 7x plus 12 divided by mod of this. Okay. So what will happen? Actually, they will cut out each other. There's no need to factorize now. So they will eventually cancel out each other. And this will be equal to, for x is equal to, for x less than equal to 3. So this will be equal to minus a upon b. Okay. All right. So let's go for f3 plus. This is equal to, for f3 plus, I'll be considering this function. This is equal to 2 sine, what was it? 2 raised to power sine x minus 3. So this is 2 raised to power sine x minus 3 upon x minus greatest integer x. Okay, so now this is for f3 plus, right? So this will be given by 2 raised to power limit x approaching 3 plus x minus 3 upon this will be x minus 3, right? Because here x is approaching 3 plus. So this will be equal to limit, this will be 2 raised to power 1. That's it. It will be 2. Now also you are given f of 3 is equal to b. Now if it is continuous, then equation 1 should be true. So from equation 1, you have f3 minus is equal to f3 plus is equal to f3. This came out to be minus a upon b. This is equal to 2 and this is equal to b. So simply, first of all, you got your b as 2. And from here, you have minus a is equal to 2b. 2b was 2. So 2 into 2, 4. A comes to be minus 4. A is equal to minus 4 and b is equal to 2. This is what you needed. Where it is, yes, ordered pair a and b. So a is equal to minus 4 and b is equal to 2. This is one ordered pair. This is only one ordered pair. That makes one option D as the correct answer. Hope you're clear with this. Next is question number 14. Let A1 till A10 be the 10 observations such that summation of all of them is equal to 50. And also you have a summation AK into AJ, where K is less than J is equal to 1100. Then the standard deviation of all of them, all of these observations is equal to. You know the formula for the standard deviation. What is that? First of all, because we will focus on what we need to find out. We need to find out the standard deviation. Now this is given by the root of summation ai square upon 10 minus summation ai upon 10 whole square. Okay, I already have this thing. I have this thing. 10 is, see what I'm taking, because n is the number of terms that is equal to 10. Okay, here are the 10 observations. Okay, I already have this thing, but I don't have the AI square. Now I need to get to the AI. Okay, now let's go to find out that. So summation, you are having k is equal to 1 till 10, a k is equal to 50. That means you have a1, a2 plus a3 till a10 is equal to 50. Let's say this is equation 1. Also, you are having summation for k is less than j. Yeah, ak aj is equal to 1100. Let's say this is the second equation. Okay, so now from 1, what you had was a1 plus a2 plus a3 till a10 is equal to 50. Let's square in both the sides. You have a1 plus a2 plus a3 till a10 raised to power 2 is equal to 50 square, which is equal to 2500. Now, this can be written as, if you will open, the formula for this is summation ai square from I is equal to 1 till 10 plus 2 summation k less than j ak into aj. This is equal to 2500 now, right? So we have to find out the summation ai square. I is equal to 1 till 10, and we know this is equal to 1100. So 2 into 1100 is equal to 2500. So summation I is equal to 1 till 10, ai square is equal to 2500 minus 2200, which is equal to 300. Okay. Now let's get back to finding your standard deviation. So standard deviation, this was equal to root of summation ai square upon 10 minus summation ai upon 10 whole square. We just calculated this was equal to 300. So 300 upon 10 minus 50 upon 10 whole square, which is equal to root of 30 minus 5 square, which is 25. So this is equal to root 5. Answer to the question, root 5. That is the option. Hope you got that. Next is question number 15. The length of the chord of the ellipse this, whose midpoint is given by this is. Okay, so the equation of the chord when the middle point is given to you is given by t is equal to s1. So that gives you x upon 25 plus y upon 16 is equal to 1 upon 25 plus 1 upon. Question number 15. The length of the chord of the ellipse, which is given by this equation, whose midpoint is given to you, is equal to. So you are having this ellipse. This is your horizontal ellipse. This is x square upon 25, y square upon 16 is equal to 1, and the midpoint is given to you as 1.1 comma 2.5, 2 by 5. So let this be any chord. Let this be this chord, and this is the midpoint of the chord, which is given by 1 comma 2 by 5. Let's say this is the point M. So now, when you are given the midpoint, the equation of the chord is always given by t is equal to S1 formula. Do remember this one. This is very important. So how will the t given now? The t is given by x into x1, which is 1 divided by 25, of course, and y into 2 by 5 divided by here was 16 is equal to, here will be 1 upon this, I'm filling 1 upon 25. So value of y, this is 2 by 5 divided by 16. So now what will be the value? Let's open it up. This will be x by 25 plus y upon this will cancel, and here will be 40. This is equal to 1 by 25 plus again 1 upon this will be square actually. I forgot to put the square over here. So this will be 4 by 25. 4 by 25 upon 16. Let's write it properly again. X by 25, y upon 40 is equal to 1 upon 25. This will give me 100, 1 upon 100. So now let's take the LCM. This will be 200 LCM. Here will be 8x plus 5y. Again, I'm taking 200 over here for the cancellation, like it will be easy for me. 8 plus 2. So you have 8x plus 5y is equal to 10, or you will have y is equal to 10 minus 8x upon 5. Now let's fill in this value of y in the given equation of the ellipse, which was x square upon 25, y square upon 16 is equal to 1. So you will have x square upon 25 plus y square, which is this thing, upon 25 into 16 is equal to 1. X square upon 25 plus 100 plus 64x square minus 160x upon 400 is equal to 1. Now let's take the LCM. This will be 400, and here will be 16x square plus 100 plus 64x square minus 160x is equal to 1. Now, okay, 16x squared plus 100. Okay, this will be 80x squared plus 100 minus 160x is equal to 400, dividing both sides by 40. No, it will be 20, dividing both sides by 20. So you will have 4x square minus 8x minus 15 is equal to 0. And solving this whole thing, you will get this value. Okay, so applying the quadratic equation, which is x is equal to minus b plus minus root of b square minus 4ac upon 2a. You will have the value of x as 8 plus minus 304 under the root divided by 8. So the two possible values of x will be 8 plus 304 under the root upon 8. Our x2 will be equal to 8 minus this. So let's find the corresponding value of y then. Y will be given by, I am having this equation for y. Using this equation, y is equal to 10 minus this will be 18 plus this. 1 minute. Here was minus, right? So here will be minus only. And divided by 8, and this will be y2, this will be y1. So you are having 10 minus 8 plus this divided by 8. So this will give me minus 8. And we go over here in the calculation of y2. What was the equation of y? That was equal to 10 minus 8x upon 5. So now let's fill in. You have y1 as, this will be 10 minus 8 into 8 plus 8 root 304 divided by 5, and y2 as 10 minus 8. 8 minus this whole thing divided by 5. All right. So here you have y1 as this will be minus 64. So minus 54 minus 304 with the root. Y. Now this was given as a 10 minus 8x upon 5. So from here, if we are having x1 value as this, the corresponding value of y1 will be given by 10 minus 8 into 8 plus 304 divided by 8 whole divided by 5, and y2 will be given as 10 minus 8 minus 304 divided by 8 whole divided by 5. Now this 8 and 8 will cancel. 8 and 8 will cancel. You will have 10 minus 8 minus 304 under the root upon 5. And this was for y1. Y2 will be given by 10 minus 8 plus 304 under the root upon 5. So this will be this value, and y2 will be 2 plus this value. Right, now let's write down the corresponding, this was y1 and this was y2. Let's write down the corresponding values of x1 and x2. For this, x1 was equal to 8 plus 304 under the root upon 8, and for this x2 was equal to 8 minus 304 under the root upon 8. So yeah, now what you have to find out? Distance. Now we are having both the coordinates. It's very easy to go. Only the, like, it's a bit complex numbers are given. Okay. Distance is given by root of x2 minus x1 square, y2 minus y1 square whole under the root. So this is given by root of x2 minus x1. When I'm subtracting both of them, it will be 8 minus 304 minus 8 minus 304 whole square plus y2 is 2 plus 304 plus 2 minus 304 minus, there will be, this was minus, so this will be plus and this will be minus, whole divided by 5 whole square. So this becomes equal to, this is 8 and 8 will cancel, and here will be 304 upon 64, and again 2 and 2 will cancel, same thing, 304, okay, 4 also, because they will be twice, right? So 4 into this upon 25. This will give me 2 into 304. Let's do the calculations. On solving this, the whole thing, you will get the root of 1691 divided by 5. So this will be your final answer. Okay, let's check with the options. You have first option as the correct answer. Hope you're clear with this. Let's move to the next question then. 4x plus 5y is equal to 20. The first quadrant is trisected by these two lines L1 and L2, which are passing through the origin. The tangent of an angle between the lines L1, L2 is given by. So let's make the figure first thing on the coordinate plane. This is the line 4x 5y is equal to 20. So when I'm putting the y is equal to x is equal to 0, y will be 4. And when I'm putting y is equal to 0, x will come out to be 5. These are the 2 points where it is cutting the x-axis and the y-axis. Now, next thing, you are having 2 lines L1 and L2, which are passing through the origin. So this is the first line, let's say L1, and this is the second line, let's say L2. And what you have to find out? Tangent of this angle theta. This is what you need to find out. Tangent of theta. Okay, now let's say L cuts this line at the point A, and L2 cuts the line at the point B. Okay, first of all, let's find out the coordinates of A and B, then only we can do anything, because we need to know the points of L and B. Tangent of theta, for that we need the slopes of both the lines, and for wanting the slopes of both the lines, we already have this origin, and we need to find the coordinates for A and B. Now consider this line. Let's name this line also something P and Q. Okay, this is the point P, which is 0, 4, and this is the point Q, which is 5, 0. This is trisected. It's given in the question. This is trisected by the point A and B. So now this is the ratio 1 is to 1 is to 1 if they are being trisected. Now, according to that, if I want to find out the coordinates for A, let's say that's A and B, and let's say that's a C and D. So A will be given by, for A, this will be 1 is to 2 ratio. So this will be 5 plus 0 upon 3. So this will be 5 by 3. And for B, it will be 0 plus 4 into 2 upon 3. So this will be 8 by 3. Similarly, this is the now this is the point 5 by 3, 8 by 3. A point 5 by 3, 8 by 3. Now let's find out C. C will be for this. Now the ratio for C ratio will be 2 is to 1. Okay. So for that, it will be 10 plus 0. Yeah, divided by again 3. So this will be 10 by 3. And for the point D, this will be equal to 2 into, it was 2 into 0 plus 1 into 4. 2 into 0 plus 1 into 4 upon 3. This will be 4 by 3. So you got the coordinates for the B point as well. This is 10 by 3 and 4 by 3. Now let's go on. We have the point origin 0, 0. Let's find out the slope of OA. This is given by 8 by 3 minus 0 upon 5 by 3 minus 0. This is equal to 8 by 5. Similarly, slope of OB is given by 4 by 3 upon 10 by 3, which is equal to 4 by 10, or this is equal to 2 by 5. I got the slopes of both of them. Now the tangent of angle between them, the formula is tangent of the angle between the two lines is given by slope of first line minus slope of second line upon 1 plus the product of the two slopes. This is equal to m1 is this and m2 is this. So you have 8 by 5 minus 2 by 5 divided by 1 by this. So you have 6 by 5 upon 25 plus 16 upon 25, or you have 6 by 5 into 25 upon 41. So this makes it 30 upon 41. So the tangent between the two lines is this 30 upon 41. That makes the D option to be the correct choice. Hope you're clear with this. Next is question number 17. Let A be this vector, B be this vector, let C be a vector such that the given one A cross C is equal to B, and the dot product of A and C is equal to 3. Okay. Then you have to find out this expression. All right, let's go. So here you have, let's clear the screen first. Fine. So first thing, I'll write down what you need to find out. You have to find out the dot product of A, C cross B minus B minus C. Okay. Fine. So now this thing, see, this is in the bracket. So I can write it like this. A cross C dot B minus. Now B vector is given to you as A cross C. A. Okay, no. I was opening up, right? So this is A dot B minus A dot C. Okay. All right. So first thing you have A cross C this. So you are given this in the question that this is equal to B. So B cross B, this is actually the modulus of B vector square minus A dot B. Let's find out this is A vector and this is B vector. So this will be 1 into 3. This will be 3. And then 2 into minus 1 minus 2. No, 3 minus 2 into minus 3, this will be minus 6. Okay. Then 1 into 1, that will be 1 into 3. I'm always missing this 3. So this will be plus 3 minus A dot C. This is 3 already given over here. All right. B modulus. Let's find out what is your B vector. B vector was 3I minus 3J plus 3K. So this is equal to 3 square plus 3 square plus 3 square, which is equal to 27. So this is 0 minus 3, 27 minus this, 24. 24 is the right answer. Option B. Hope you're clear with this. Then let's move to the next question, number 18. Now you're saying A is the limit x approaching 0, 1. Okay, this whole expression, and B is given by this. You have to find out A, B, Q. See, one thing you can do, you can rationalize the numerator and denominator, but that will be a lengthy process. Instead of that, I'll be using the binomial approximation in this question. What does that say? So here you have 1 plus x raised to power 4. Okay, I'm taking up this one, 1 plus x raised to power 4. This can be written like this. So according to the binomial expression, now this will be 1 plus half into x raised to power 4. Okay, so let's write down. I'm picking up the A. First of all, I will not write A. I'll just write down this thing. 1 plus x raised to power 4 power 1 by 2 whole divided by x raised to power 4. So this will be root of 1 plus half into x raised to power 4 whole divided by x raised to power 4. So this will be 2 plus 1 by 2 into this. Or I will write it better like this. 2 plus 1 by 2 x power 4 raised to power 1 by 2 whole divided by x power 4, right? So now again, what I need over here for the binomial expansion, I need 1 over here. So I will be taking root 2 outside. This will be 2 upon 2, 1 plus here will be 1 by 4 because dividing by 2 raised to power 4, 1 by 2 whole divided by x raised to power 4. This is for a only. So this will be this, and here will be 1 plus 1 by 4 into 1 by 2. That will be 1 by 8 raised to power this, whole divided by this. Okay, so you have root 2 plus root 2 upon 8 into this. One thing I missed in the question, this root 2, I didn't write that. Minus root 2, minus root 2, minus root 2, minus root 2, minus this, and minus this. This will cancel. And you have root 2 upon 8 into this upon this, or you have 2 upon 4 root 2. Okay, this was your value because I didn't need for x approaching 0. This was your value for a. Okay, let's say this is 1. Now let's go on to find the b. So b is given to you as this. Let's write down. B is equal to limit x approaching 0 sine square x whole divided by root 2 minus this. This thing. Okay, so now let's do this thing. I'll multiply the numerator and denominator by this. Into root 2 plus 1 plus cos x divided by this will be a square minus b square. Okay, so this will be given by limit x approaching 0 sine square x, and I'll open up the sine square x. Okay, I don't find anything I can do except than this. Limit x approaching 0. Now this will be 1 minus cos square x root 2 1 plus cos x over here. So this will be 1 plus cos x. So this one open, it will be, 1 minus cos square x is this, right? Into 1 minus cos x. So they will cancel. I'll be left with 1 plus cos x in the numerator. And now danger part is gone. I don't have any 0 in the denominator. So that's it. Now you can fill in cos x, x is equal to 0. This will be 1 plus cos 0 is equal to 0. Root 2 plus root 2. So this will be 2 into 2 root 2. This will be 4 root 2. This is your value for b. Now what you have to find out is ab cube. A was this value. No. Okay, this is 1. Okay. So A is this and B is this. A, B cube, A is equal to 1 upon 4 root 2 and B is this. This will cancel, like 2 will be there. So 4 root 2 square, the answer will be 32. Okay, so this is the answer to the question 32. Option B stands to be the right one. Hope you are clear with this. Let's move to the next question then. Question number 19, consider the matrix fx given by this. Now, you are given two statements. Statement 1 says f minus x is inverse of the matrix fx, and also fx into fy is equal to fx plus y. In the light of the above statements, you have to choose the correct answer from the given ones. So, first statement, it says f of minus x is inverse of fx. The two matrices A is an inverse. Let's say B is an inverse of A. B matrix is inverse of A matrix if the product of both of them is equal to identity matrix. That means if the product of f minus x and fx is equal to identity matrix, then they are inverse of each other. Okay. So f of minus x, this is given by cos minus x minus sin minus x, 0, sin minus x, 0, cos minus x, 0, 1, 0. So this f of minus x will be given by, this will be cos x, sin x, 0, minus sin x, cos x, 0, 0, 0, 1. Now let's multiply both of this, fx and f minus x. Fx and f minus x. This will be given by, your fx was equal to, this was cos x minus sin x, 0. This was sin x, cos x, 0, and 0, 0, 1. Multiply by, this one was cos x minus sin x, 0, sin x, cos x, 0, 0, 0, 1. That's fine. First row, first column. So this will be cos square x plus sine square x. And then you will have a first row, first column. You will have sine square x, first row. Wait, first row, second column now. Okay, so first row, second column, you have a sine x, cos x minus sine x, cos x, 0. Now, second row, first column, sine x cos x minus sine x cos x. Again, here you will have a sine square x plus cos square x. 0, 0, 0, 1. Okay. You know, sine square x cos square x, that's equal to 1. So this will be equal to, they will cancel. This will be 1, 0, 0, and 0, 0, 1, 0, 0, 1. This is your identity matrix. That means, yes, they are inverse of each other. Statement 1 is correct. Okay. Second one, fx into fy is equal to fx plus y. So you already have this fx. This is cos x minus sin x, 0, sin x, 0, cos x, 0, 0, 1. And this was your fy. This is cos y, sin y, 0, minus sin y, cos y, 0, 1, 0, 0. Let's multiply both of them. So you will have cos x, cos y minus sin x, sin y. Under the first row, second column, minus sin y, or I will write down cos x first. Okay. Now, first row, second column, you have a minus cos x sin y minus sin x cos y and 0. Then you have here sin x cos y plus cos x sin y. Then you have sin x minus sin y plus cos x cos y, 0, 1, 0, 0. So this is, this is equal to cos x minus y plus y. And this is equal to sin x plus y. Here is 0. This is minus will be outside, sin a. This will be sin x plus y. This will be cos x plus y, 0, 1, 0, 0. So this is equal to f x plus y only. That means the second statement is also correct. That means both are correct. And yeah, you have the third option, last option, D. This is the right answer to the question. Hope you're clear with this. And let's move to the next question, number 20. The function f defined by this is defined by fn. Fn is the highest prime factor of n. Now this function is both 1, 1 and onto 1, 1 only, onto only, or neither of them. See, you are given that Fn is highest prime factor of n. So that means f of 2, that's equal to 2, and f of 4 is also equal to 2. So that means this is many to one function, not 1. Okay. Now the second thing, 4 is not the image of any element. That means it is an onto function. Sorry, into function. All right. So that means it is a many one and into function. So the answer to the question is option D. Neither 1 nor onto. Option D is the right answer. Question number 21. The least positive integral of alpha for which the angle between these two vectors is acute is what? First of all, when you are having two vectors, let's say A and B, the dot product of the two vectors is equal to their magnitude product multiplied by the cos of angle between them. So cos of theta will be equal to the dot product of the two vectors divided by their magnitudes. Here the two vectors are this and this. So this will be given by alpha I to j to k dot product with alpha I plus 2 alpha j minus 2k. This is divided by root of modulus of the first factor. So this is alpha square plus 4 multiplied by alpha square plus 4 alpha square plus 4. So you have, let's write it again, cos theta, this will be on solving alpha square minus 4 alpha minus 4 upon this multiply this. Now you're given that theta is acute. For that, it will be positive. It will be greater than 0. So if this is greater than 0, obviously they can't be negative. That means alpha squared minus 4, alpha minus 4 will always be greater than 0. Let's factorize. So this will be alpha minus 2 whole square will be greater than 8, adding 8 on both sides, right? And you will have alpha minus 2 will be greater than this 2 root 2 and plus minus. Okay, so this will be the one, and from here you will have alpha is greater than 2 plus minus 2 root 2. That means alpha is greater than 2 plus 2 root 2 and alpha is less than 2 minus 2 root 2. So that means what will be the range of alpha? According to this, the alpha will be, see, first of all, here, if I solve this, you will get the approximate value as 2 plus root 2. This will give me the approximate value as 4.82. And here, the approximate value will be 0.82. So now alpha will lie in the range of minus infinity 0.82 union 4.82 and infinity. Okay, so yeah, the least positive integral value of alpha. First of all, you have to find the least positive integral. So least and positive and integral value. According to this, so from here, it will be 5 only. Alpha can be 5 because there's a least positive integral value of alpha. All right. So the answer to the question is 5. Hope you're clear with this. Let's move to the next question then. Question number 22. Let the differential equation f0 to infinity belongs to R, fx minus fy greater than equal to log x upon y to the base e plus x minus y for all x, y belonging to this, then the value of this expression is equal to what? So according to the given expression, fx minus fy is greater than equal to log x upon y minus plus x minus y. This can be written as a fx minus fy is equal to log x minus log y plus this, dividing both sides, you will have fx minus fy upon x minus y is equal to log x log y upon x minus y plus 1. Now let's say x is greater than y. For that, limit y approaching f dash x minus will be greater than equal to 1 by x plus 1, equation 1. And let's say x is less than y. For that, limit y approaching x if x plus is less than equal to this. Let's say this is equation 2. Okay. So now f dash x minus is equal to f dash x plus according to the question. So you have a from here you will have f dash x is equal to this, or f of 1 upon x squared, this will be equal to 1 upon x squared plus 1. So therefore summation from x is equal to 1 to 20 x squared plus 1 is equal to summation x is equal to 1 to 20 x squared plus 20 times x, right? So 20 times 1, so this will be plus 20 only. Now this is equal to 20, you know, this is given by n into n plus 1 into 2n plus 1 upon 6. Okay, so n is 20, so n into 21 into 41 upon 6 plus 20. Let's solve this. On solving this whole thing, this will cancel 7, 3, 10. Okay, so this will be 2, 8, 9, 0. This is the answer to the question 2890. Hope you're clear with this. Let's move to the next question. Question number 23, the solution of the differential equation given by this. This is the differential equation. I'm repeating the question. If the solution of the differential equation, this is equal to 0 and y naught is equal to 3 is this much. Then what is alpha plus 2 beta plus 3 gamma? So let's write down here three things in the question. Solution of the first of all the differential equation 2x plus 3y minus 2 dx plus 4x plus 6y minus 7 dy is equal to 0. This is the differential equation and the solution for this is given as alpha x beta y 3 log 2x 3y minus gamma is equal to 6. All right. Okay. Right. And also you are given y naught is equal to 3. That means when x is equal to 0, y is equal to 3. That's it. So let's pick up this. You noticing one thing, this is 2x plus 3y and this is 4x plus 6y. So let's say 2x 3y minus 2 is equal to t. This gives you 4x plus 6y minus 4 is equal to 2t. Okay. Or you can say 4x plus 6y. I need a minus 7 over here. So this will be minus 7 is equal to 2t minus 3. Okay, let's differentiate here both sides with respect to x. You will have 2 plus 3 dy by dx is equal to dt upon dx. All right. So now according to the question from this differential equation 1, from 1, you have dy by dx is equal to minus 2x plus 3y minus 2 divided by 4x plus 6y minus 7. If I write in the terms of t, this will be minus t divided by this will be 2t minus 3. Okay. Now let's fill in this value in this equation. You have 2 plus 3 into dy by dx is equal to dt upon dx, or you have 2 plus 3 into minus t, 2t minus 3 is equal to dt upon dx, or you have a 4t minus 6 minus 3t upon 2t minus 3 is equal to dt by dx, which will give you dt upon dx is equal to t minus 6 upon this. All right. So you will have here not integration. So here you will have a 2t minus 3 dt upon t minus 6. is equal to dx. Now let's do the integration of both sides. Here you will have a, first of all, before solving the integration, this is 2t minus this. I'll 2t minus 3. I'll do one thing, adding and subtracting 12. 2t minus 12, t minus 6, and adding a 9 like this. Hope you're clear like what I've done. So this will give me 2 dt plus 9 I'm taking outside, 1 upon t minus 6 into dt is equal to integral of dx. So this will give me 2t plus 9 natural log t minus 6 is equal to x plus c. And here you had x as, t as 2x plus 3y. I'm filling in the value of t minus 2 plus 9 natural log 2x plus 3y minus 2 minus 6. I'm writing minus 8 is equal to x plus c. Okay. Now you are given in the question y0 is equal to 3. That means when x is equal to 0, y is equal to 3. So let's fill in that. You have when x is equal to 0, y is equal to 3. So this will be 9 minus 2, which is 7 plus 9 log of 0 log 1 is equal to 0 plus c. Or you will have c as this will be 14. C's value will come out to be 14. So let's fill the value of c over here in this equation. Let's say this is equation 2. So from 2, you will have 4x plus 6y minus 4 plus 9 into log 2x 3y minus 8 is equal to x plus 14. Or you will have this will be giving me 3x plus 6y plus 9 log 2x plus 3y minus 8 is equal to 18, right? Okay. So I'm dividing both the sides by 3. So you will have x plus 2y plus 3 log 2x 3y minus 8 is equal to 6. 3. Yeah, 6 over here. Okay. So if I compare it with the given equation, the solution is this equation. Let's write down the equation. You had this as alpha x, and then you had a beta y 3 log natural log 2x plus 3y minus gamma is equal to 6. So from here you have alpha is equal to 1 and beta is equal to 2, and gamma will be equal to 8. That's it. What you needed to find out was alpha, 2 beta, 3 gamma. So this is 1 plus 4 plus 24, which is equal to 29. So the answer to the question is 29. Hope you're clear with this. Let's move to the next question. Question number 24, let the area of the region given by xy such that x minus 2y plus 4 greater than 0. This represents a line, and these two represent a curve. Where y is greater than 0. Y is greater than equal to 0, be m by n. So where m and n, they are the co-prime numbers, and then you have to find out the value of m plus n. So this is the figure which represents these three. This is your line, which is given by this equation, and the rest two. This is the curve, and these are the two curves. Now you have to take y is greater than 0. First of all, let's find out the point of intersection of all of these. You have the first curve as if I change the inequalities to equalities. So this is x plus 2y is greater than 0. Let's say this is equal to 0, and the second one you have x minus 2y is equal to minus 4. This is the equation of the line. So minus plus plus, here you will have a 2y square plus 2y is equal to 4, or y square plus y minus 2 is equal to 0, or you will have here, this will be y square plus 2y minus y minus 2 is equal to 0, or this will be y plus 2 minus 1, y plus 2 is equal to 0. You'll have the two values of y that is equal to 1 or minus 2. All right, so now the second point of intersection. So now I'm gonna take this in this curve x plus y square. I'm changing the inequalities to equalities. X plus y 4y square is equal to minus 8, and x minus 2y is equal to minus 4. Okay, minus plus plus, they will cancel, and you will have 4y square plus 2y is equal to minus 4, or 2y square plus y. Wait, this will be, this was 8, not the minus 8. Okay, yeah, so here will be 12. This one will be 12. So this minus 6 is equal to 0. Okay, now you have 2y square plus 4y minus 3y minus 6 is equal to 0. 2y, let's take common. Y plus 2 minus 3, y plus 2 is equal to 0. So you will have 2y minus 3 or y plus 2 as the row factor. So that means y can be equal to 3 by 2 or minus 2. Now the third one, the point of intersection of the x plus 2y square is equal to 0 and x plus 4y square is equal to 8. Minus minus minus, they will cut, and you will have a minus 2y square plus 8 is equal to 0, or you will have y square is equal to 4, or y will be equal to plus minus 2. So these are the point of intersection of all of them. Now you have to find out this required region. Look over here. You have to find out this region given over here. So which is shown over here, this one. Okay, the shaded one. This one is the region you need to find out. So let's go for this. Required area will be given by integration. Now you have to take only the positive values. So I will not be taking the negative values for the intersection of y, because here in the question you are given that y is given equal to 0. So from 0 to 1, this is 8 minus 4y square minus 2y square dy plus integration from 1 to 3 by 2, 8 minus 4y square minus 2y minus 4 dy. Right. So now let's solve it. So required area, this is given by, okay. So this was integration dy. Okay, fine. So this is 8y minus 4y cube upon 3. Right. 4y cube upon 3 is and it's plus minus minus plus. Here will be 2y cube upon 3. Limits 0 to 1 plus limits here will be 8y minus 4y cube upon 3 minus 2y square upon 2 minus minus plus 4y, limits was 1 to 3 by 2. All right, so let's simplify this. You have 8y minus 2y cube upon 3, limit 0 to 1, plus this is 12y minus this will be y square, and 4y cube upon 3 limits this. So this will be equal to, let's fill in the values now. You will have 8 minus 2 by 3 plus this is 3 by 2, 6, 3 is 18 minus 9 by 4 minus 4 by 3 into 27 by 8, then minus 12 minus 1 minus 4 by 3. Okay, so this will give me 24, 22 by 3 plus 18 minus 9 by 4. Here will be the reduction cancellations. 9 minus 9 by 4 Yeah, minus this will be 11 minus 4 by 3. So this will be 22 upon 3 plus this will be minus 9 by 2 minus 11 plus 4 by 3. So 22 by 3 plus 7 minus 9 by 2 plus 4 by 3. Let's take the LCM. There was a small mistake. It was 2 and it should have been 2 over here. So that makes a whole sum. I'll redo this one. Okay. So now from this step, this will be 22 upon 3 plus 18 minus 9 by 4 minus 9 by 2 minus 11 plus 4 by 3. Now this will be equal to 22 by 3, 18 minus 11, 7, minus 9 by 4, minus 9 by 2, plus 4 by 3. Let's take the LCM. So here you have 12. This will be 4 and 88, and this will be 84 minus 27 minus 54 minus 16. So let's do the calculation. This will be 107 upon 12. So this is equal to m by n. That gives you m value as this, n value as this. You have to find out m plus n. So this is equal to 119. This is the answer to the question 119. Hope you're clear with this. Let's move to the next question, number 25 then. So if 8 is equal to 3 plus 1 by 3, 3 plus p plus 1 by 4 square, 3 plus 2p. See, this is AGP series, infinite. Because you have a combination of the arithmetic and the geometric progression over here. You are moving in the arithmetic. See, this is P, this is 2P, then you have 3P, so on. And you also have the geometric progression, 1 by 4, 1 by 4 square, 1 by 4 cube, and all that. So given series is AGP. That is arithmetic geometric progression. Here A is 3 and your D, that is a common ratio, not the common ratio, common difference is equal to P. And then you have the common ratio as 1 by 4. And there's a formula for the AGP. Formula for infinite series of AGP. Series for AGP is given by A upon 1 minus R plus common difference into common ratio upon 1 minus R whole square. So you have A as 3, R as 1 by 4, plus D is P in this case, and what do you have? R. 1 by 4 upon 1 minus 1 by 4 whole square. So this will give me 3 divided by 3 by 4 plus P by 4 divided by 3 by 4 whole square. This will give me 4 plus this will be P by 4 multiply 16 by 9. So this is equal to 4 plus 4P upon 9. You are given in the question that this is equal to 8. So you have 4P upon 9 as 4. That gives you P is equal to 9. That is it. You wanted to find out the value of P. P comes out to be 9. So you have option. Okay, there's no option, but answer to the question is 9. Hope you're clear with this. Let's move to the next question, number 26 then. A fair die is tossed repeatedly until a 6 is obtained. Let X denote the number of tosses required and let A be equal to probability that in the third attempt you attain a 6. B be the probability that in the third attempt more than 3 attempts are required to obtain a 6, and C be the probability given by this. Okay, this is a division. Now you have to find out the value for this expression. All right. First of all, we are not sure how many times the number of tosses are taking place. Right. First thing, A gives you the probability that in the third attempt you get a 6. First of all, P, this is the number of winning, like you get a probability of getting a 6. This is 1 out of 6. So what will be the probability of not getting a 6? That will be 5 by 6. Now, for getting the third attempt, you get a 6. This is given by 5 by 6, that is q raised to power 2 into p raised to power 1. Okay, so this will give me 25 upon 216. Now the B says, that means you got the A value as this. Now B says that it is a probability that you get a 6 in more than 3 or like attempts. Okay, so this will be, see, this will be given by that you get, it may be 3, probability getting a third attempt, 4 attempt, 5th attempt, so on. Like, I don't know how many times it will be. Let it be infinity only. Okay, so this is given by 5 by 6 raised to power 2 into 1 by 6. 5 by 6 raised to power 3 into 1 by 6. 5 by 6 raised to power 4 into 1 by 6 till infinity. So now this is a GP series. First term, 5 by 6 raised to power 2. Common ratio is 1 by 6. So what is the sum of it? This will be given by, B will be given by, which is equal to this. It will be given by A, which is this upon 1 minus R. So you have 5 by 6 square into 1 by 6 upon 5 by 6. This will cancel with this and you have 5 by 36. Yes. Okay, this 5 is also there, right? So this will be 25 by 36. This is your value of B. What does the C says you? For C, I want to have the value for x greater than probability x greater than equal to 6. Now, again, this will be probability you get on the 6th attempt, on the 7th attempt, and so on. This is given by 5 by 6 raised to power 5, 1 by 6, 5 by 6 raised to power 6, 1 by 6, so on. This is your first term. Common ratio is 1 by 3. So probability that x is greater than 6 attempts, you get it. This is given by 5 by 6 raised to power 5 into this upon this. So this is 5 by 6 raised to power 5 into 1 by 6 upon 5 by 6. So this will cancel at 4. See, there is one small mistake I have been doing here. The R is 5 by 6, not 1 by 6. Okay, give me a minute. See, you're getting in the multiples of 5 by 6, right? So here R is 5 by 6. This will be 5 by 6. So this will be 1 by 6. And then it will be, of course, 25 by 7. I did the mistake over here also. So this cancels. This cancels. Okay, this will be 25 by 6. And here also, this is 5 by 6. So I'll redo this thing. This is equal to 5 by 6 raised to power 5. 1 by 6 upon 1 by 6. So this is equal to 5 by 6 raised to power 5 only. Okay, and probability x is greater than 3. This is given by probability x is equal to 4. Probability x is greater than 3 is given by the probability you get the 6 in 4th attempt, 5th attempt, and so on. So again, this is equal to 5 by 6 raised to power 3 into 1 by 6, 5 by 6 raised to power 4 into 1 by 6, and so on. This is again a GP. So this is given by first term divided by 1 minus common ratio. Common ratio is 5 by 6, not 1 by 6. Okay. So this gives me 5 by 6 raised to power 3, or this is 125 upon 216. All right. So now let's get the value of C. C is given by this. So I'll be using this and this value. So C is equal to 5 by 6 raised to power 5 divided by 5 by 6 raised to power 3, which is equal to 5 by 6 raised to power 2, or this is equal to 25 upon 36, right? That's your value of C. Now let's write down all the values. We got the value of A as this, B value came out to be this, and C also came out to be this. Let's write it. This is 5 square upon 6 cube. 5 upon 6 square. 5 upon 6 square. Just let me check once again. B was equal to, okay, fine. Yeah, clear. Okay, so what you had to find out was to find B plus C upon A. B is this, C is this upon A is this. Okay, this gives me 2 into 5 by 6 raised to power 2 divided by 25 upon 216. Or this will be 2 into 25 upon 36 multiply 25 into this. So they will cancel. This will cancel at this was 6 raised to power 2 and this is 6 raised to power 3, right? So this will be at 6. Yeah. So this comes out to be 12. That's it. You have 12 as the answer. Hope you're clear with this, right? Yeah. I think you're clear with this thing now. I told you this is 1 upon 1 minus 5 by 6. Your common ratio is 5 by 6. That's it. Yeah. So let's move to the next question. Question number 27. Let the set of all a belonging to real numbers such that equation cos 2x plus a sine x is equal to 2a minus 7 has a solution b, p, comma, q, and r is given by this equation. You have to find out the value of p, q, r. So here, let's start with the first one. You are given the equation cos 2x plus a sine x is equal to 2a minus 7. Let's try and make it, see, cos 2x, if I convert it into, this can be like sine square x. This can be written as 1 minus 2 sine square x minus a sine x minus 2a plus 7 is equal to 0. Or this will be 2 sine square x plus a sine x plus 2a minus 8. Wait, this will be plus 8, right? So I'll be taking minus outside. Right. I'm multiplying both the sides by minus, so this will be 2a minus 8 only. Okay, fine, this is right. Now, there's a quadratic equation in sine x. So let's find out the roots. Sine x will be given by, it's given by minus b plus minus this. So here is, this is b, a is b, this is your b, this is your a, and this is your c. This will be given by minus a plus minus b square, which is a 4, 2, 2, a minus 4. I have taken 2 common from here, divided by 2a, which is 2 into 2. Okay, so this will be equal to minus a plus minus a square. So we a 16 minus this upon 4. And this will be given by minus a plus minus. See, this is the root. This is root of a square minus 16a plus 64 upon 4. Or this is equal to minus 8 plus minus root of a minus 8 whole square upon 4. Okay. See, now we had one thing in the question. I don't know what a carries the value. A belongs to real numbers. A may be negative. A may be positive. So according to that, I will write this sine x as sine x can be written as minus a plus minus mod of a minus 8 upon 4, right? So now it can have values. It can be minus a plus mod a minus 8 upon 4 or minus a minus mod this much upon 4, right? So this will be, again, I'll be taking the negative and the positive values. This will be minus a plus 8 minus 8 upon 4. This is sine x, or minus a plus 8 upon 4. So here this will cancel and this is not possible in any case. And here will be minus 2a plus 8 upon 4, or this will give me 8 minus 4 minus a upon 2. Okay. Yeah, let it be like this only for the time being. Now this one. This will be minus a plus 8 upon 4 or minus a plus a minus 8. Okay. Yeah, so upon 4, this is again not possible. And here do you have the same thing, minus 2a plus 8 upon 4, or you have 4 minus a upon 2. So these are the two values, 4 minus a upon 2. Yeah. So that means both are the same, right? So that means sin x is equal to 4 minus a upon 2. Now you know sin x lies between minus 1 and 1. Sin x lies between minus 1 and 1. So that means this value will also lie between minus 1 and 1. So minus 1 less than equal to 4 minus a upon 2 less than equal to 1. This will be minus 2 less than equal to 4 minus a less than equal to 2. Or you will have, here it will go on this side. A will be 4 minus a. Minus a less than equal to minus 6 less than equal to minus 2. Right? Yeah. So here, if I'm changing the signs, like multiplying all the sides by minus, you will have a is less than equal to 6 is less than equal to 2. Okay, so this is your range of a. Now let's get back to our question. What do we have to do? I just forgot that. Okay. So it has a solution P comma Q. Okay. So it has a solution P comma Q. That means A belongs to 2 comma 6. That means according to the question, this is your P and Q. 2 is your P and let's write it down. This is your P and this is your Q. I have to find out P, Q, R. I'm done with the two variables P and Q. Let's go with R. R said you, R is equal to this expression. Now let's pick up this. R is equal to tangent of 9 plus cot of, what is it? Tangent of 9 minus 20, tangent of 27 minus tangent of 27 minus 1 upon cot 63 plus tangent of 81. This can be written tangent 9. I'll keep these two as such. So I will write it as tangent 90 minus 27 plus this will be cotangent 90 minus 9. This will be equal to tangent 9 minus tangent 27 minus this will be wait, this will be, sorry, this was cotangent 90 minus this. Okay. Wait, I will rewrite these lines. So that was equal to, wait. Okay, so this is cotangent 90 minus 27 plus tangent 90 minus 9. Okay, now I've done it correct. So this is tangent 9 minus tangent 27 minus this will be tangent of 27 plus this will be cotangent of 9. This is equal to tangent 9 plus cotangent 9 minus tangent 27. This will be cotangent 27. Let's open it up. So here will be tangent square 9 plus 1 upon tangent 9. I have opened cot 9 as 1 upon tangent of 9. Also, I'm opening cot 27 as 1 upon tangent of 27. So this is a minus tangent square 27 plus 1 upon tangent of 27. This is secant square 9 upon tangent 9 minus secant square 27 upon tangent of 27. This gives me 1 upon sine 9 cos 9 minus 1 upon sine 27 cos 27. This is equal to 4 upon 2. I'm taking common 4 upon this minus 1 So this is equal to, I'm taking 4 also outside, 8. So this is root 5 minus 1, root 5 plus 1. Here will be root 5 plus 1 minus this plus 1. They will cancel. You will have 8 into 2 upon 5 minus 1, which is equal to 4. So you will have 4 as this value of R. So we got all the values. We solved for PQ. P came out to be 2. Q came out to be 6. R we solved as 4. So PQR, that is equal to 48. So this is the answer to the question 48. Okay. That's it. Let's move to the next question, number 28. Let fx be defined by this function, which includes the second, first, second, third derivatives of f. You have to find out f dash 10. Okay. First thing, you have the function x cube, x square, f dash 1, x, f double dash 2, 3 for all x belonging to R. So let's find out the first derivative. You have f dash x is equal to, this will be 3x square plus 2x f dash 1 plus f double dash 2. Second, this will be 6x to this. Third, see, because this is a constant, okay? Similarly, this is a constant, so this will be equal to 6, right? Now, let's find out f dash 1. F dash 1 on solving, see, I have to solve f dash 1. What I'll do is, I already have this value. F dash x is equal to 6 is a constant. I'll fill in over here. And f dash 1, this is given by 3 into 1 square plus 2 into 1 into f dash 1 plus f double dash 2. Also, let's find out f double dash 2. Now, this is equal to 12, 6 into 2 plus 2 into f dash 1. Okay, now let's fill this over here. You will have f dash 1 is equal to 2 plus 3 f dash 1 plus 12 plus 2 f dash 1. Okay, this will give me minus 3 minus 12 is equal to 4 minus 1, that is equal to 3. F dash 1 here will be plus. Okay, so this will be minus 15, so minus 5. I got f dash 1 is equal to minus 5. From here, you will have f double dash 2, second derivative, 12 plus 2 into minus 5, which is equal to 2. Let's write down all the values. I have f dash 1 as minus 5, f second derivative 2 is equal to, I just solved how much? 2. And the third, it's those 3 or whatever, like it's x, okay? Whatever the value of x doesn't matter, it's always x. Now, let's get back to your f dash x. I have to find out f dash 10, right? So let's get back to our f dash x. That was equal to this. Let's fill in. F dash x is equal to 3x square 2x f dash 1 plus f double dash 2. So this is 3x square 2, this is minus 5, and this is 2, 3x square minus 10x plus 2. This is your f dash x, f dash 10. Simple question, right? So this is minus 100 plus 2. This will be 202. This is the answer to the question 202. Hope you're clear with this. Let's move to the next question. Next is question number 29. A is this matrix and B is given by B1, B2, B3. This is again a matrix where B1, 2, 3, they are the column matrices. Okay. You are given AB1 is this, AB2 is this, AB3 is this, and alpha is equal to the determinant of P matrix. You have beta is the sum of all diagonal elements of P. You have to find out alpha cube plus beta cube. In short, you have to find out P. for the question. Okay, so you have this A, let's say B1 matrix is, it's a column matrix. So it's this x1, y1, z1, x2, y2, z2. This is B matrix, and B3, x3, y3, z3. Okay, so now you have A, B1 is equal to 1, 0, 0. You have A, B2, 2, 3, 0. A, B3, 3, 2, 1. Right. So let's write down what your A matrix was. 2, 0, 1, 1, 1, 0, 1, 0, 1. X1, Y1, Z1. This is equal to 1, 0, 0. Similarly, for the second and for the third. So second, 2, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0. This into x2, y2, z2 is equal to 2, 3, 0, 2, 0, 1, 1, 1, 0, 1, 0, 1. This x3, y3, z3 is equal to, this is 3 to 1. Okay, so now let's do the multiplication. First row, first column, you will get this as 2x1 is equal to 1. That gives you x1 as 1 by 2. Wait, 2x1, no, sorry. This is, I haven't noticed it. So here will be, okay, first row, first column, this will be 2x1 plus z1 is equal to 1. Then you have x1 plus y1 is equal to 0. Then you have x1 plus z1 is equal to 0. That means x1 and z1, they are opposite of each other. You have x1 is equal to minus z1. Okay. So from here, you will have, I'm using this equation now. So 2x1 minus x1 is equal to 1, or you have x1 is equal to 1. That means z1 will be equal to minus 1. And on solving, you will have y1 also equal to minus 1. You have these values for x1, y1, z1. That means your B1 matrix came out to be, B1 is 1 minus 1 minus 1. This is the B1 matrix. Now let's go on to finding x2, y2, and y3. So you have 2x2 plus z2 is equal to 2. You have x2, y2 is equal to 3. And you have x2 plus z2 is equal to 0. So that means x2 and z2, they're opposite of each other. I'm again using this equation, 2x2 minus x2 is equal to 2, or you have x2 is equal to 2. If I have x2 is equal to 2, the value of z2 will be minus 2. And y2 will be equal to, this will be 1. Okay, so your B2 matrix, this is equal to 2, 1, and minus 2. Now let's go on for the third one. You have 2x3 plus z3 is equal to 3. x3 plus y3 is equal to this, or x3 plus z3 is equal to 1. Okay, so you have z3 as 1 minus x3. So this equation now will be 2x3 minus 1 plus 1 minus x3 is equal to 3, or you have x3 is equal to 2. Okay, if I'm getting x3 is equal to 2, z3 will be equal to minus 1, and on solving, you will get y3 as 0. Right? Because, yeah, it will be 0. So that means your B3 matrix, this becomes 2, 0, minus 1. Okay, so these are your B1, B2, B3 matrices. Now, what was your B matrix? It was this. So B matrix is, using all of them, B matrix becomes 1, 2, 2, minus 1, 1, 0, minus 1, minus 2, minus 1. Okay, let's find out the determinant, because alpha is equal to determinant of B matrix. So determinant is given by 1, minus 1, and 0. This and this. Okay, so plus 0, minus 2. This will be 1 and 0, minus 2, 2, minus, minus, plus 1. Okay, so this will be equal to minus 1, minus 2, and minus 6. Okay. Sorry, here was plus right here. So this will be 3. So determinant of B is equal to 3. That means you got your value of alpha is equal to 3. Now, what about the beta? Beta is sum of all diagonal elements of B. So diagonal elements of B, let's solve beta over here. So beta is the sum of diagonal elements, that is equal to 1 plus 1 minus 1, that is equal to 1. I got the value of beta as 1. And you have to find out alpha cube plus beta cube. This is equal to 3 cube plus 1 cube, which is 28. So this is the answer to the question, 28. Hope you're clear with this. Next is question number 30. This is the question number 20. This is the last question of this paper. If alpha satisfies this equation and 1 plus alpha raised to power 7 is equal to this, A, B, C, they are greater than 0, and you have to find out the value of this expression. So you have the equation 1 plus x squared is equal to, 0. The roots are given by omega or omega squared. The roots for this equation are given by omega and omega squared. So you are given alpha is one of the root. Let's say alpha is equal to omega. You can take any value, no problem. Okay, so now 1 plus alpha raised to power 7, this will be equal to 1 plus omega raised to power 7. You know one identity, 1 plus omega square is equal to 0. So you have 1 plus omega as minus omega square, or minus omega raised to power 7. This will be minus omega raised to power 14. Okay, so minus, this can be written as 12, 3 into 4, that is 12. Let's write it as like this, 12 plus 2 omega raised to power 12 multiply minus omega square. So this is equal to 1, omega cube is equal to 1. So this will be equal to, sorry, this minus will not be carried over here. Okay, so this will be equal to minus 1 into omega square, or this will be omega square, or this will be 1 plus omega only. All right. So now that was equal to A plus B alpha plus C alpha square. This is equivalent to A plus B alpha plus C alpha square. Right. So here your A is equal to 1, B is equal to 1, and C is equal to 0, because I don't have omega square over here. Right. We had to find out. It was a very easy question indeed. Right. You have to find out 5, 3a minus 2b minus c. That's equal to, let's check. You have to find this only, right? So now this is equal to 5 into 3 into a minus 2 into b minus 0. So that gives me 5 only. That's it. This is the last question, and pretty easy one. Actually, maybe it's a gift. So that's it. You have all the questions of JEE Mains mathematical part done over here. And students, hope you understood them well. Students, with that, don't forget to visit our website www.examsnet.com. Here you will find all the entrance exam question papers with the detailed PDF solutions. Also, you may download our app. The link is available in the description box. So students, a very best of luck for your exams. Keep shining, keep rising high. That's all for this paper. A very best of luck. Bye.